Today I am going to present the topic self-confidence. Briefly, if we delve into the historical aspects of this self-confidence, how these self-confidence have arisen in those days of 1950s. Sulfonamides are the first antimicrobial agent designed to treat pyogenic infections. Pyogenic means first forming infections. First is rich in para-aminobutyric acid, purines, plus heme. Next, coming to how sulfonamides have entered into the arsenal of antimicrobials, we have to tell about Gerard. Donak is a base scientist who is working on a miracle rhodocilate. Actually, this rhodocilate is a dye. This is sulfonamide trisulfide. He started the concept of prodrugs indirectly. So what Donak has done is he has done experiments in vitro as well as in vivo. In vitro experimentation, he took a petri dish. He placed the culture of this Staphylococcus aureus and provided a sufficient nourishment. Kept for incubation for 48 hours. At the same time, this Staphylococcus aureus culture has been inoculated incubated with this protozoo bread. And at the same time, this donor has injected the Staphylococcus aureus bacilli into healthy mice. So they developed infection. After that, he has administered this protozoo bread. Here, after observing for a period of 3 or more days, this bacteria that is present in vitro, that is present in petri dish, have instead not killed but they increase in number. So the protozoo has not shown any effect. Next, here the mice infected with Staphylococcus aureus bacilli, so they got infection. After that, he has given protozoo, they were cured. The bacilli concentration in the fluids has drastically reduced. Why it happened? Why it can't inhibit here but has inhibited here? Then he came to know that inside the living beings, even though bacteria is also living being, but the metabolic enzymes are not present that are going to convert into active drug. Here in rats, upon the administration of the drug, protozoo bread, its azole linkage was removed by the azole reductase present in the mice, so that it has converted into active form, sulfonamide moiety form. This sulfonamide moiety form has become an antibacterial. Like this, the concept of prodrug has arrived later. Albert has clearly defined that prodrug is an inactive form of the drug upon metabolic activation converts into active drug and shows its pharmacological action. This is the historical aspects of sulfonamides. Next, sulfonamides are the examples for structure-based drug discovery. What happens upon sulfonamides administration? The scientists have observed hypoglycemia. Then they came to know that if we structurally alter the structure of the sulfonamides, we can employ this as anti-diabetic or oral hypoglycemic agents. Like that, the sulfonylureas have been abandoned. Next, apart from that, this sulfonamides upon administration has caused diuresis. Based upon that, they structure, they have This structural alteration that leads to diuretics like carbonic anhydrous inhibitors as well as anti diuretics because may also share the structural similarity. So the sulfonamides formed an example for structure based drugs. Next, coming to the classification of sulfonamides, these sulfonamides have been classified based upon systemic use, oral use, and special purpose use or topical use. We can say simply. Here in systemic use, they have been classified based upon the duration of action. One is the short acting, 4 to 8 hours, intermediate acting, 8 to 12 hours, long acting, approximately equal to 7 days. So the short acting drugs sulfosamide and sulfadiazine, whereas intermediate acting drugs sulfamethoxazole is quite important. Later we are going to discuss about this drug. Next, long acting drug is sulfadoxide. Doxide. Whenever the word contains dox means it will be long acting. Sulfadoxide and pyrethroid combination is there, well effective for anti-malaria. As anti-malaria. Next, for oral use is sulfasalazine. Sulfasalazine. Here it's also a prodrug. It's also a prodrug. Here this sulfasalazine contains sulfadiazine plus 5-aminosalicylic acid. Sulfadiazine plus 5-aminosalicylic acid. Actually, this drug is made for ulcerative colitis. Ulcerative colitis. Actually, in this drug, this is also a prodrug. Here, if a person is suffering from ulcerative colitis, we have to treat the inflammation. It's an autoimmune kind of disorder. So, if we administer this sulfasalazine, what happens means it is gastric irritant. So, to avoid gastric irritation, we have combined with this sulfonamide. So, it will reach the colon where the azoretic layers that are present in the colon are going to remove the link. So, the drug divides into 5-aminosalicylic acid as well as sulfadiazine. Here, 5-aminosalicylic acid acts as anti-inflammatory analgesic plant. Whereas sulfonamide, even though it may serve as antibacterial, but its sulfadiazine is the carrier agent here. Next, coming to the special purpose, means here the burn therapy is there, ophthalmic application is there. Burn therapy, silver, sulfur, we will use it. Here the silver is also having antibacterial action. And the same way, methylate acetate is there. Methylate acetate. Actually, when we know about methylate acetate, it's not a true sulfonamide. Actually, methylate acetate has a methylene bridge between the benzene ring and the amino link. That's why it's not a true sulfonamide. Actually, sulfonamides are going to be inhibited by the PABA, but methylate acetate is not being inhibited by PABA. So, it is used for drug infections. Next, coming to the structural aspects of sulfonamides. When we see the structure of sulfonamide, here we see 1,4 parapositions. Here, this is N1 at first position. This is responsible for pharmacokinetics, enhances. So, if you do any alteration, it affects the solubility as well as potency. Whereas it is the N4 is responsible for antimicrobial activity. This N1 can be substituted to alter the pharmacokinetics, whereas N4 should be free so that the antimicrobial activity will be preserved. Actually, when we administer the sulfonamide in liver, it undergoes metabolism, non-microsomal metabolism, that is, N will be N4 acetylated metabolite. We have told that N4 should be free for antibacterial activity. Here, upon introduction of this acetyl group at N4, the antibacterial activity will be lost. So, that metabolite is ineffective as antibacterial agents. Next, we come into the mechanism of action. Sulfonamides are going to inhibit dihydroteroate synthase enzyme. So upon the inhibition of dihydroteroids, we don't get dihydroteroic acid. Next, we don't get dihydrofolic acid. We don't get tetrahydrofolic acid. We don't get one carbon full of coenzymes. So that there will be no synthesis of purines, pyrimidines, proteins, etc. etc. So this antibacterial activity is established. When coming to the spectrum of action, these are narrow spectrum. Sulfonamides are narrow spectrum. They do not cover anaerobic organisms. Yes, when it comes to the bactericidal or bacteriostatic activity, these are bacteriostatic. Means they inhibit the growth of the bacteria, not they are going to be sided. This is about the great things about sulfonamides. Next, we coming to the adverse effects of the sulfonamides. Sulfonamides has various adverse effects. One is the Stevens-Johnson syndrome. It's a type 4 hypersensitivity reaction. It's a milder form of the reaction. The other spectrum of the disease is the toxic adrenal necrolysis. Next, you for urticaria, some sulfur drugs have allergy, so urticaria is there. And at the same time, there was crystalluria. Crystalluria. All crystalluria happens means, say for example, the normal pH of urine is slightly acidic. During infection, the acidity will be much more increased upon sulfonamides administration because they are going to concentrate in the urinary tract. So, urinary tract infection, this is the better. What happens in these sulfonamides, the pKa is different from the urinary pH, though in urinary bladder they get concentrated, so crystals will be formed. It's called crystalluria. How to overcome this crystalluria means we have to take plenty of water. Apart from that, we can administer sodium bicarbonate. Next, we have designed the sulfonamides such that their pKa suits with the pH of the urine at the during the infectious conditions. Next, cavities. We can see cavities. Say for example, if a newborn baby is suffering from septicemia kind of infections, if we administer sulfonamides, what is going to happen? Now sulfonamides are rarely used because their most advanced drugs are there that better cure the infections. So the infant's liver has not matured enough to produce sufficient conjugative agent. In such cases, if he is suffering from infection, if we give him sulfonamides, what happens means actually there is hemolysis, so it produces excessive bilirubin. This bilirubin will be bound to the human serum albumin. Yes. Generally, the liver starts functioning slowly. So, initially, it doesn't produce much amount of the UDP glucosidase transferases that conjugate the bilirubin to flush out of the body. In such circumstances, if you given sulfonamides, these sulfonamides displaces the bilirubin that is bound to human serum albumin. So, this bilirubin concentration will be more. This unconjugated bilirubin will be more. Unconjugated bilirubin will be highly lipophilic. It can cross the brain. In brain, it can damage the basal ganglia, dopaminergic neurons, so that the infant will suffer from cerebral palsy. So, sulfonamides are having these kinds of adverse effects.